It just so happens that 3 days ago, we celebrated, or rather observed, Veterans Day, which was instituted to commemorate the Armistice Day, November 11th, 1918, exactly 100 years ago this week. The end of World War I. In the fall of 1918, despite the cheery faces that you see here in London, the largest pandemic ever recorded in human history by number of victims was ravaging the entire continent. In fact, it was ravaging the entire globe. It was due to this critter, a virus, H1N1, which we still deal with today. It's one of the various strains of influenza, an avian strain of influenza. It claimed the lives of 50 million people and infected 500 million around the world, 1/3 of the total population of Europe, 1/3. In today's figures, it would be 240 million dead and 2.4 billion people infected. Imagine that. 240 million is almost the population of the entire United States. And 2.4 billion is India plus China put together. Imagine the impact. This on top of 8.5 million killed during World War I and 37 million casualties, that is wounded and lost. So it wasn't a very good time to be alive 100 years ago. And many have tried to figure out why this strain of the flu spread so fast throughout the continent. And explanations have come from many disciplines, usually from a single discipline, few from multidisciplinary studies, but very few have considered the environmental record. And so again, we go back to Colin-Fetti. We looked at our environmental record, and we found something very remarkable. The largest peaks in sea salt concentration in our record were the 5 years right before the pandemic hit. The 5 years before the pandemic hit, every year we have a peak. And it's sea salt because the sea salt indicates the arrival of cold, wet weather dominated by the Iceland low pressure system, which is one of the two pressure systems that influences the weather over Europe. This climate anomaly was so extreme that it was, in fact, memorialized in photos and diaries and other and of course, instrumental records too, throughout the war. World War I was the war of the mud. It was the war where craters filled with water. It was the war where trenches filled with water. It was the war where tunnels built to reach the other side, to reach beneath the enemy lines, were filled with water. Torrential rains that flooded and sometimes drowned soldiers. Soldiers lived 24/7 in this muck. And so we know now from our ice core record that this was in fact an extreme weather anomaly unlike anything else in our record. So we wanted to see what the impact was of this anomaly on mortality and on the flu itself. And so we went again into the historical record and found the highest resolution mortality rate from the European continent, week by week, calculated for 13 different countries. Overall mortality, including casualties of war. I should say, actually, people killed in action, because casualty means wounded. So these are just killed in actions plus all other mortality. And we see every time we have a peak in sea salt, that is the wet, cold weather, torrential rain, we have a peak in the mortality. You can see it here, maybe even better with my other pointer. And then, because we really want consilience, that is, we want multiple independent data sets to agree and tell us the same story, we matched two other records, both instrumental, of precipitation and temperature. And you can see here the Spanish influenza. The red is the mortality, the blue is the temperature, and look at the shape. So that is the impact of this extreme weather anomaly on influenza. Influenza happens, this particular strain of influenza happens to thrive in cold, wet weather. It happens to be transmitted throughout its vectors, animal vectors, mostly birds, via water, contaminated water with droppings. I've read a lot of papers about bird droppings for this paper. One of the things I never thought I would do, but hey, science doing it past. And imagine living in that water. Imagine that the water is infecting animal populations. It may very well have infected the human population through zoonosis, the jumping of the disease from the animal to humans. As we look at the impact of climate, of extreme weather on, I don't think I have to make this point because we've seen enough cases of extreme weather in the last few years. But if we look at the impact of extreme weather on the health of a population, of the global population, we should be informed by this example as we look at similar crises that are happening today. Today already, the climate crisis that we are experiencing is impacting pathogens and making pathogens that are usually circumscribed to certain ecosystems reach well beyond. Zika is an example. Dengue fever is another. Malaria is another. The vectors are reaching way farther than they used to because the environment is changing and making it easier for those vectors to reach areas that before they could not reach. So as we think about climate change and our current crisis, this approach, this case study can inform us and help us craft new policies that can hopefully prevent the worst. I would like to thank the best team that one could possibly wish for. I would also like to thank the Arcadia Fund of London for funding this project. And I would be happy to take your questions. Thank you.